Perfect. Thank you very much. Hi, everyone. I hope you can all hear me well. So I'm going to be talking about a project, Project Cola. This is a research project that was funded by the European Commission as part of the Horizon 2020 program. And it started in January 2017 and lasted 30 months. It included 10 companies and 4 research organizations from 6 European countries. And the aim of the project was to increase the adoption of cloud computing services by small and medium enterprises and public sector organizations. And it was, the objective was to define and provide a reference implementation of a generic and pluggable framework that supported optimal and secure deployment and runtime orchestration of cloud applications. So that's what I'm going to be talking about. And in fact, I'm going to talk about Mikado, because Mikado is that framework. So Mikado was what was produced by Project Cola, and it's now on version 0.7.3. So it's still in its early stages, but there's a lot there, and I'm going to be talking about that. So Mikado is an open source and highly customizable multi-cloud orchestration and auto-scaling framework for Docker containers orchestrated by Kubernetes. So a lot of words, quite complicated, but hopefully I can break it down for everyone. I'm going to talk about the use case demonstrators. So in the project, we had 3 use case demonstrators, each with 2 partners. Outlandish was one of those, part of one of those use case demonstrators, and we're working with the audience agency on a project that we've worked with them on in the past called Audience Finder. Audience Finder is a data dashboard for arts organizations in the UK, and it uses ticketing and survey data to build up a picture of an organization's audience, and then provides that through various charts and metrics to the different arts organizations in the UK. And it was already on the cloud, but it wasn't making use of the cloud infrastructure. And so Mikado promises to allow Audience Finder to make better use of the infrastructure that it runs on, making better use of the resources, and not having empty resources that aren't being used. So it can horizontally scale the application to meet the demand of its users. The second use case demonstrator was Seika Solutions and Brunel University. Seika Solutions runs simulation modeling for evacuation planning. So when a nuclear power station melts down, it's their job to make sure that people get out on time. They use sophisticated scientific software to model how people move in a situation. And they run through thousands of scenarios in order to find sort of the optimal best planning for a particular scenario. They were not using cloud infrastructure at all. So their simulations were being run on computers in their offices. And so it took as long as the computer was going to take, and often that was very slow. So Mikado promises to offer Seika Solutions a way of horizontally scaling the computing power that they have available for their simulations, so they can have a quick turnaround on their projects. And then the final one was Anycom and Saga. So they were working in partnership with the Aragon local government in Spain. The Aragon local government uses social media information to provide, to communicate with their citizens. And they wanted to use sentiment analysis on social media to understand better what their citizens were talking about, and then provide the sort of answers to their questions and concerns as quickly as possible. And Mikado can provide Anycom with a way of scaling that infrastructure up to meet the demands of what can be quite a demanding system of reading through all those tweets and Facebook posts. So what is Mikado? Mikado is a modular framework that allows you to plug in different components to scale an application on cloud infrastructure. It uses Kubernetes to orchestrate the containers. So if you are familiar with Docker, then you'll be familiar with Kubernetes, which is now sort of the default go-to orchestrator for Docker containers. But it also has a number of other features, all part of the framework. So first of all, it uses Tosca, which is a standard document formats for describing applications. And it includes a Tosca submitter here in the diagram, which takes in a ADT, or application description template, which describes the application that is going to be deployed to the Mikado framework. And that will describe the Docker containers. It will describe the virtual machines that those Docker containers will be running on, and it will describe any scaling policies that the ADT developer will want to put in. The Tosca submitter then passes that information and passes it on to three parts of Mikado. Kubernetes is, as I've already mentioned, the orchestrator for the Docker containers, which the application will run in. Octopus is a system for communicating with cloud infrastructure. So the ADT would include information about what VMs to set up and start producing, and Octopus will then speak to the cloud infrastructure that you're running Mikado on and start building those VMs, which are listed on the right. And then finally, there's Policy Keeper, and Policy Keeper is in charge of, after the initial setup, of scaling those Docker containers and virtual machines. And what makes this different from just sort of a Kubernetes or other similar frameworks is we use Prometheus to understand what virtual machines and containers and the applications are doing. So Prometheus is a software for measuring and showing time series data, and that can come from anywhere. So by default, it can come from the virtual machines, and that can be the CPU usage and memory usage and stuff like that. It can also speak with Kubernetes, and so it can understand what containers are being run and what their CPU usage and memory usage are like. But you can also write your own Prometheus exporters to export metric data from the software that's being run in those Docker containers, and even from very specific things about your application. So you can get very detailed about what metrics are being used to scale those applications, those containers and those virtual machines. The ADT is sort of like the real gritty part of Mikado, and understanding how to write your ADT was a really big part of the project. So I'm going to go through quickly what an ADT looks like. Firstly, an ADT is written in YAML, and if anyone has written sort of a Kubernetes application description, you'll recognize a lot of these sort of features, as Kubernetes is the key part of the Mikado framework. But here we describe, this is an example application, and here we're describing the container. So this is the Docker container that's going to be run in Mikado, that'll be running the application. And it allows you to describe where the image is going to come from. So in this case, we have a name for an image, which is Docker stress ng. And then you allow to pass arguments through to that Docker container for when it's being run. And you can also specify resources that the container must be allowed. So if those resources aren't available on a VM, then Kubernetes won't put that container there, and will try and find a virtual machine that it can run on. Then we also describe the cloud instance. In this case, we're describing a Cloud Sigma cloud instance, which is a cloud infrastructure much like AWS. It has information about the drive image that it should be using. So that's the machine image that the virtual machine will be created as using, and that can be whatever you specify. A public SSH key, so you can connect to that, and so Mikado can connect to that. And then additional firewall policies that you need for security. So this is the virtual machine that the application containers will be running on. And then we can describe monitoring policies. So this is where we're describing the ways in which we're going to monitor the application. So we can describe container metrics and node metrics, but we can also use third-party Prometheus exporters, which we can describe here as well. And we can also describe the scaling policy here as well. So we can describe some constants. So we've got a threshold max, which is where the what we're going to be using in the actual scaling policy. And then finally, we have a scaling policy here. And you'll notice at the bottom, the scaling policy is just Python. So you can write in Python a scaling policy using metrics from Prometheus and also any other properties that you might find in the scaling policy itself. And here we've got a few alerts that we've described. And what this policy is going to do is it's going to say when the CPU usage of the container goes up and goes over a particular threshold, then we'll scale up that container and scale up the underlying virtual machine as well. So in the example application I'm going to go through and demonstrate with a video, it's a very simple web WordPress application with three containers, three parts. So we have an Nginx application, which is going to be running our web server. We have a WordPress container, which is going to be the scalable part, which is going to be running PHP FPM. And then we have a Redis container, which is going to be supporting WordPress so that it can scale up. So the Nginx container has no scaling policy, but it has a Prometheus exporter to export metrics on the web server, which can be very useful for understanding how the web server is behaving. It's using a custom image with static files for the application and with corresponding configurations so that we can just deliver static files from the Nginx container without going through to PHP. And then we're using a command line tool called msubstitution to template in Nginx configuration files for different environments. So you can set using environment variables. The WordPress container does have a scaling policy, and we're going to be basing that scaling policy on PHP FPM, which is the processes that will be responding to the web server and then producing the content that will be sent back to the user. We have a Prometheus exporter, so we can understand those PHP FPM metrics and make use of them in Mikado and the scaling policy. And we're using a custom image again with those application files embedded in there. And then we're also using that command line tool to customize the PHP configuration and also the WordPress application configuration. And then finally, we have a Redis container, and we're using that just to support the, so with WordPress, when you log in, you start a new session, and that session data is normally saved to the file system. But obviously, when you're dealing with horizontally scalable microservices, as we are here, you need to be able to make those stateless. So in this case, we're storing that session data in the Redis container. So I'm going to move over to the video now and show you what that looks like. And on to stop sharing. And okay, so this is a video of so a deployment has already happened to the Mikado instance that we're running. And this is going to be load testing on the application that I just described. So here we have the Kubernetes dashboard with the various containers that are acting in this, this setup. And we also have a corresponding Grafana dashboard, which is going to be showing the Prometheus metrics. And we're going to be looking in particular at the PHP FPM metrics that we're going to be using for the scaling policy. And here we have the average number of active processes, and that is the metric that we're using in this demonstration to scale the WordPress containers. And I'm using Locust here, which is a Python tool for load testing web applications. So I've started the job off here with 35 users, ramping up, and that's going to start hitting this web server, and we're getting response times here that are going to raise up as we put load on the server. And then here we're showing that as we start hitting the server with requests, that's going to start hitting the load on the server. I'm just going to skip ahead. So here we can see that the average number of PHP FPM processes have increased to 100%. So we're now overloading the system, and people are going to start getting poor response rates from the web server. But we've now scaled up to 2 containers, and you can see those listed below. And that has seen a dramatic decrease in the average number of active processes because we now have more WordPress containers as part of the web server and responding to the request. And you can see in the chart that we now have there was a big increase, and then we saw a big decrease as that new container joined the system. So now we can increase the number of users to simulate up to 50. And we can see that the load will start going up even further now. And we've got three lines here. The green line is the average, and then the yellow and blue are showing the actual numbers coming from the individual containers. I'm just going to skip forward a little bit here. So we're now going to increase that number to 75. And that's going to see a massive increase in the number of average active processes. And again, that's the amount of requests that are being sent against the web server. And that's jumped up to 70 now, and now it's 95. So we're now going to start, we're in the red zone, so we're going to start adding new containers. And in this demonstration, I have said that there can be no more than 2 WordPress containers on a worker node. And so Mikado will also start adding new virtual machines to the Mikado framework. So new containers can be added to those new virtual machines. I'll just skip forward to where that's happening. So obviously it takes a bit longer to get a virtual machine up and running. But we now have a 3rd container added, and these will, on the right-hand side, we've now got 2 worker nodes in play, and this will update to be 3 containers in a second. So you can see that there's been a big drop-off in the number of average active processes. And we're now be able to accept more things, and we'll be adding a 4th container very soon. So in the chart, we can see that we saw a big increase in the response time, and then as the new virtual machine was added and more containers were added to the system, we saw a big drop off towards the end. So when the load decreases, and here we've gone down to 1 user, so that's going to decrease the load on the web server. We're going to start seeing a decrease in the load on the PHP FPM containers, and that's going to allow us to scale down the system in response to that, so that we're not wasting resources when no one's using the site. But this takes a little bit of time, and that's just been the setup that we've got defined in the scaling policy. But as we skip forward, we'll start seeing that the number of containers and worker nodes starts to drop. So we've now got another 3 containers. Oh, shit. And I've quit there. So that's the end of the video. The really exciting part of the Mikado framework is also the job related stuff. So with Mikado, you can have a list of jobs to finish in a particular time. You can define that you want to, say, finish 1,000 jobs in 20 minutes, and it will know how many containers and virtual machines to scale up in order to reach that deadline. And that's what the Seika solutions use case is using. So they have a number of simulations to run, and they want to run that in a certain amount of time. And so they can tell Mikado that we need to finish 1,000 simulations and we need to do it in an hour. And then they'll tell how long each simulation runs, and then Mikado can obviously scale that up. And then if it turns out that actually we need to save a bit of money and we don't want to scale up too much, you can also tell Mikado that your policies have now changed and your scaling policy is now different. So there's it's still very early days with this framework, but there's some really exciting stuff, particularly around the ability to sort of scale in response to the needs of the application, rather than in response to the resources being used by that application, which is probably the most exciting part. So that is the demonstration, and now I can answer any questions that you might have.
Thank you. It was great, the presentation. It was so clear. I don't know if there is any question.
So there, I've got some. I'll share the presentation with everyone, and I'll also share a list of sort of like links, so if you want to find out a bit more. But you can start using Mikado now, so it's all open source software, and it's been released, and as I said, it's on 0.7.3. And there's documentation to read to have a look at that. And I would be happy to help anyone who was interested in giving it a go. We use Ansible for deploying the Mikado framework and also deploying the application to that. And we also use Ansible and the Ginger to templating in Python to actually create those application description templates. And there's also going to be application description templates, so there's ADTs, for example, applications, which you can then sort of use as a starting point for writing your own descriptions. And the other great thing that we've started doing at Outlandish is actually using Prometheus for just monitoring and alerts on a more general basis within our infrastructure. So we use more traditional infrastructure for a lot of our clients' work, and we started using Prometheus as part of this project, because of this project, to sort of monitor the status of those resources. So there's a lot of sort of crossover now that we're using, but we're not yet using Docker containers in a production environment yet.
I have one question.
Yes.
Yeah, every time that Outlandish develops something, you are the person who takes care about deployments and taking care about these kind of things. This is your role in the cooperative.
Yeah, that's right. So I'm the sort of lead DevOps person, and I've taken on the role of sort of managing our servers.
Okay, so when Outlandish development is sold, you sell this as part of the service. That's right.
Yeah, so we provide hosting solutions for our clients, and they often we do host their work, and most of the time it's a very simple setup, but sometimes we need to sort of design sort of very sophisticated setups, and we use Ansible for all of for doing all of that. Okay,
thanks. And well, I have one more. What are the technologies that you work on? Which is your stack? I mean, you developing which technologies?
Oh yes, so Outlandish works primarily in PHP and Node.js. We do a little bit of Python, but mostly for command line tools and for as part of just Ansible. And then we use Ansible primarily for the deploying infrastructure and managing the applications running on our servers. So those are really the three technologies that we use for applications.
Great, thanks. I don't know if anyone has one question. No?
Perfect.
This is too difficult to ask a question, so yes, they are afraid of the answer.
Yeah, I can imagine.
So no, because I think this is a great, well, this space is meant to be the place where cooperatives can talk about technology and by that process get to know each other better. So I will always take the opportunity to ask these kind of questions in order to know what are the technologies that you use, or which kind of projects do you usually develop. I know that Outlandish always develops projects with social impact.
Yeah,
right?
That's right. Yeah. So we're working a lot with charities and unions in the UK at the moment. And in fact, actually relating to Mikado and sort of the scaling up of an application to meet demand, we're doing a lot of campaign websites at the moment. So obviously being able to meet demand when someone like Greenpeace sends out an email to 1 million people to say, come and visit this website. We need to understand how to create the infrastructure that will allow that to not crash on everyone.
Great. Well, I don't know if there is a question. Is it there? Yes. Patcon, hello.
Hey, I arrived late and I apologize, but it sounded wonderful for the second half. My question was related to what tools you use and that the kind of hint that you or do social impact work or you aspire to. And I was wondering, how do you balance? I, there's been some threads in the Coop Tech forum and about balancing like how hardcore we be about open source and how when we prioritize maybe a closed source solution that's a little more rounded. I'm curious how Outlandish prioritizes open source versus the giving, helping change the shape of the world of the social mission work most effectively, which,
Yep.
yeah, I sometimes worry how compatible those are in certain moments.
Yeah, I think it's really difficult, and obviously we're using Zoom at the moment, and that is not open source software. I think that there's definitely should be a drive towards using open source software, because I think open source software is the way in which we can be more cooperative in the software industry. But at the same time, we need software that works and provides the tools that we need and makes it easy to work together. And oftentimes, some closed source solutions are the better. So I think that we should support and help the open source community as much as possible. But we should also use the best tool for the job to try and to achieve the goal, which is to communicate better and achieve a better world through cooperation. And sometimes that means sort of, taking a shortcut and doing something using something that's maybe not the most open piece. But we should always try to aspire to do better and maybe help to achieve that.
I agree.
Yeah, we wanted to send emojis instead of on your face, like the heart and freedom emoji.
Yeah, we need that.
Yeah, but I guess everyone struggles with that. We also struggle with that, using what we can in terms of open source, but rarely is there's just open source that we can use for a project. And we hope that as you become more stable, then you can invest more time in maintaining things or establishing new things. But you need to survive and do your job well right now.
Yes.
But equally, like with Kubernetes, for instance, or Docker in general. So I didn't know about Mikado at all, but it's a lot of stuff with DevOps that is open source, isn't it? And yeah, with our sort of computer vision stuff as well. But there's like those nasty packages in the middle frequently that you cannot live without.
Yeah. Well, I don't know if anyone has a question, something to say. Just take the opportunity to talk with our cooperatives here. This is the idea.
I don't think so. So far, so good. Thank you for the explanation, Matt.
Well, thanks everyone for coming along to my presentation. The project has been running for 2 years now. Well, yeah, longer than 2 years, and it's coming to an end now. But I think that Outlandish is going to continue using the skills and the technologies that we've picked up and started using because of the project. It's been really interesting. I think that my experience of it it's been very academic. So the project itself has really been focusing on sort of like the academic research possibilities for the project, and it's been difficult to really get into that space. But I think that these kind of research projects where you can, it's really useful to have a sort of some people who are working in the industry to come in and start talking to, because sometimes it can be very difficult to get sort of something out of it unless you have these sort of use case demonstrators. I would very much recommend that people follow these kind of research projects that are happening, because often it's a way for example, the EU is doing this project because they want to develop alternatives to the sort of like the big tech company solutions to these kind of things, and ones that are sort of produced with, in this case, the European Union in mind. So it's about developing cloud software that can work with these sort of smaller cloud hosting providers. And I think that's another area where cooperatives, it's really important for cooperatives to get involved with, to support sort of the local industry. That so I guess that's in kind of in relation to the open source question just earlier, which is that oftentimes open source solutions come from a much wider community, and it's important to have those perspectives when developing software, because if you have a very sort of insulated and insular community developing software, then you can miss out on maybe the needs of the people who will be using your software. And there's lots of sort of funny examples of that, not so funny examples of that kind of stuff happening. So moving technology outside of the sort of the big areas, the top technology is sort of like developed and sort of congregated, is really important for making technology democratic in that sense.
Just this morning, we went to a workshop, as a peer design workshop organized by Coop. I don't know if you heard about them, but they also got EU funding to develop a peer-to-peer cloud storage system. So of course, like a lot of issues there, but the idea is great, and it seems like that they are actually trying to reach out to different groups that could potentially use it, and sort of confront all the ambiguities there, about the replication or version control, and trust as well, and how do you personalize this, but they actually go around and talk to different groups, not necessarily like techies, and have this attitude, kind of listening attitude that is bringing together strictly sort of software development from, let's say, the kind of like blockchain angle with like community building sort of thing. So I'll probably they will keep us posted about it, but it sounds cool, and they've already got something running, so we'll see where that goes. But yeah, also micro scale that could potentially scale up, if the infrastructure is solid enough. But it's EU almost, has a priority to just build something independent to the tech giants, as you said. Yeah, it's definitely happening. So have a good weekend.
Yeah, have a lovely Friday, everyone.
Thanks so much, man. It was great.
Thanks for attending, and remember that we will be having the next show and tell the last Friday of each month. So the next one is the last Friday of October.
Nice one. If you're in London tomorrow, there's a party in our housing co-op if you want to drop in. Okay.
Great. I will start my travel today. See you tomorrow. Have a nice weekend.
Bye, everyone.
Bye.
Bye. Thanks.